Good morning or afternoon, whatever time you're watching this. We are going to look at our exponents today, and starting with exponent rules. You might be familiar with some of these already. Our product rule, when we are multiplying like terms, we add their exponents. The power rule, if you raise a term to another power, you multiply their exponents. Power of a product, this just means that if you have two terms being raised to a power and they're being multiplied, you distribute it to both. But if they're not both being raised, like there's not a parentheses around the a and the b, this power only applies to the m. One you might not be super familiar with is negative exponent. That just means it's on the wrong side of your fraction. So if it was in a numerator, you would need to move it to the denominator, vice versa. Zero power, anything to the zero power is 1. Quotient rule, when you're dividing like terms, you subtract their exponents. Power of a product, similar to this one, if it's in parentheses and you're raising both terms, you have to do that for your numerator and your denominator. And then fractional exponents will get its own thing today, but essentially the denominator for your exponent is the index for your radical, and the numerator is the power on your base. So we are going to start with everything except fractional exponents to start. So here on problem 1, I have 4. And we're assuming that that is 4 to the first power. And if I'm multiplying that by 4 to the third, that means my result will be 4 to the 1 plus 3 power. And that is 4 to the fourth. And I can actually evaluate that. It is a real number. You can use a calculator if you wish, but it is 256. All right, I'm going to continue going down the line in order. 2. I have 3 squared. And then that's being raised to the 6th power. So taking care of my power rule first, this is going to be 3 to the 2 times 3 power, which is 3 to the 6th. That is an actual number. Again, you can use a calculator, but it's going to be 729. Looking at 3, this is power of a product. All of these are inside multiplied together, and they are all being squared. So I have to apply that to all 3. And these are a power being raised to another power. So 3 to the 2 times 2, x to the 2 times 2. And then we're going to assume that y has a power of 1 here. So that's to the 1 times 2. So that will give me 3 to the 4th, x to the 4th, and y squared. And 3 to the 4th is a real number. Again, you can use a calculator. So that will give us 81 x to the 4th, y squared for number 3. Moving on to 4, m to the 7th times 1 over m to the 4th. That is the same thing, if I were to multiply this out, as m to the 7th over m to the 4th. So that is my quotient rule, which means I will subtract, and I will have m to the 7 minus 4 power, which is m to the 3rd. Moving on to 5. This one is a combination. I'm going to start by simplifying my denominator first. So I have a product rule in the denominator, which means I still have 8 to the 9th on top, but the bottom will be 8 to the 3rd plus 5. You're going to add those two exponents. So that will give you 8 to the 9th over 8 to the 8th. Now I can focus on my quotient rule, which is where I will subtract my exponents. So I will just end up with 8 to the first power, which is 8. Okay, on D, this is using a couple different things. We are using our polynomial operations of multiplication and product rules here. So I have to multiply everything that are like terms together. So I'm going to have 2 times 3, which will give me 6. Then I'm going to have x to the 3rd times x to the 4th. So that means I'm going to add those two exponents. And then I have y to the 5th times y squared. So that's going to be y to the 5 plus 2 because I have to add. So my final result is going to be 6, x to the 7th, y to the 7th. Okay, on 7, this is a product rule. So 4 to the negative 2 times 4 to the 6. I will add those two exponents. And negative 2 plus 6 is 4. So 4 to the 4th, which we already found in problem 1 here, is going to be 256. All right, last one on 8. What I'm going to do first is distribute this power using my power of a product rule, and then I will take care of the negatives. So this is going to give us x to the negative 4 times the negative 2. and then y to the 5 times the negative 2. Negative 4 times negative 2 will give us x to the positive 8, and then 5 times negative 2 will give us y to the negative 10. So x has a positive power, I'm not worried about it, but the y has a negative. So to fix that, I have to move it to the denominator, and my final answer will be x to the 8th over y to the 10th. Okay, these last two are a little different. Starting on 9, 3 squared times 3 to the x gives me 3 to the 10. So what that means is, if I was going to use my power rule, product rule, I have to add my two exponents. So this would be that 3 to the 2 plus x equals 3 to the 10th. So 2 plus whatever x is has to equal 10. This is a simple one-step equation, and I find that x is 8. 10 is similar, except this is going to use our quotient rule instead. This is going to say that 3 to the y minus 4 has to be equivalent to 3 to the 5th. So that means that y minus 4 has to equal 5, and if I were to add 4 to both sides, I would get that y is 9. All right, so that fractional exponent rule, as promised, is what we are going to focus on next. So remember, radicals. So if you have an index written, it is that root. So third root, fourth root, fifth root, etc. When there's none written, we are assuming it's a square root, and so that n value would be 2. So you can rewrite radicals as exponents with 1 over whatever your index on your radical is. And if you have a numerator and your denominator, this can be rewritten as a radical. Again, the denominator is the index for your radical, and then the numerator stays a power. And you can write this both two ways. You can raise the entire radical to that power, or you can raise what's inside your radical to that power. Either way, with order of operations, you get the same result. So let's practice rewriting these with exponents. So this is the square root of x, so that index on our radical is 2. So this would be equivalent to the x to the 1/2 power. That is the same thing as a square root. Okay, on b, I have the cube root of 6x. So that's to the 1/3 power. And because both the 6 and the x are inside my radical, I need to put them in parentheses because this is kind of like our power of product rule. If it's not in parentheses, it doesn't apply to both. So if I want both things to end up inside my radical, I need to make sure that they are in parentheses. Moving on to c, I have the square root of x to the 5th power. So my index on that radical is 2 because it's a square root, so that's going to be the denominator for my exponent. And then because it's to the 5th power, that will be my numerator. So x to the 5 over 2. Moving on to d, I have the cube root of 3x to the 4th. So 3x, both parts are in my radical, so I need to make sure it's in parentheses to be specific that the exponent applies to both. The index of my radical is 3, so that's the denominator of my exponent. And then because it's to the 4th power, that is my numerator. All right, now moving on to example 2 here, we are going in reverse. We are going to take our exponent and rewrite it as a radical. So if I have x to the 1/3, that is the cube root of x. If I have x to the 1/2, that is the square root of x. If I have 7x to the 4/3, firstly, because this is in parentheses, that means both things need to be inside my radical. So the cube root of 7x, and I can raise that to the 4th power here, or I can put the 4th power inside my radical, but I need to make sure that I'm being very clear that everything applies to both the 7 and the x. On d, 3x to the 2/3, this is going to be cube root of 3x, and again that whole thing is being squared, or I can put the square inside my radical, but I need to be specific that the square applies to both. All right, last part for the day, we are looking at negatives. Again, remember this means that your exponent is in the wrong part of your fraction. So you either need to move it to the numerator or the denominator, but we also need to be very careful about what it applies to. So on a, because I do not have parentheses around the -4 and the x, this exponent only belongs to the x. So that is the only thing that's going to move to my denominator to make the exponent positive. Same story on b. The exponent only touches x, so only the x will move to the denominator. Now on C, I've got parentheses around this whole thing, so that means the entire thing is being raised to the negative 2 power. So I'm going to move the entire thing to the denominator, and then that will make my exponent positive. And then on D, now the 5x is in parentheses, so both parts need to move to my denominator. So it's 5x to the third power, which we could distribute out. 5 to the third power is 125, and then I would have x cubed. So big takeaway here is pay close attention to your parentheses, what applies to what, and then rational exponents are a little new, so you might need to take some extra time when working those problems.